This is New York City, New York, one of the most finest places in the United States of America. This car is traveling according to its speedometer. Approximately, it is traveling at about 200 kilometers per hour. But the question is, how fast can this car go? Simply, we can call this car car number 1. Car number 1 is traveling in about 129 kilometers per hour, going up to 135. But typically, it's following its traffic guidelines. Occasionally, it might bump into other cars, but it might still follow its traffic guidelines. Following this speed limit, their limits are no limit. But how can we determine this car's speed? Simply by its speedometer. Right now, this car is traveling approximately about 200 kilometers per hour. Typically, it might bump into other cars, and to trees, and into other objects that it might see, according to gravity and inertia. But why do cars crash suddenly? This could be considered as gravitational forcible inertia. Let's try some objects that go with this term. Look at the 2 dice. Notice how these two have 2's on them. They equal 4, in which this case, 2 times 2 equals 4. Now watch what happens. Now it's 4 plus 4, or 4 times 2, which equals 8. Now watch what happens if we roll the 2 dice again. Just wait for it. Wait as you watch. Now it's 1 plus 3, which simply, it equals 4. Simple, isn't it? Or you can do 3 plus 1, equaling 4. Now watch what happens as we roll the dice again. Now it's 6 plus 5, which equals 11. Simple, isn't it? Because 5 plus 6 equals 11. In which this case, 6 is exactly the nicest number, in which it stays the same. Now the yellow dice has a 2 in place, which equals 8. Now have a glance at this. What do you see from here? Well, typically it's soccer balls bouncing up and down. But watch what happens when we drop TNT. Of course, it'll explode. Do you see what's happening? Typically, the soccer balls are being carried by the wind. Because explosions are very strong, wind can be strong too. And that is why soccer balls can't take it, because they're so light that it might be carried away from the wind, or it could be called gravitational wind. Now have a glance at this. What do you notice about this? But now, take a look as I place down lots of anvils. At the bottom, it is used for dynamic physics, using gravity, and its single use. Here, I am using lots of objects, and a lot of TNT, of course. Personally, I love TNT. Now look at this scenario. This scenario is almost like a racing scene. This man is about to get hit by cars constantly. But this is almost as dangerous as being hit by a car realistically. Let's look at what happens when he gets hit by a car. Typically, he survives. But the real point is that if you get hit by a car, you're dead. But that's not the case. You might see a constant variable of getting hit. But watch. Did you catch that? That car was being hit by a red car. That car that this man was riding was getting hit by a red car. Why did it get hit? This is because of force and inertia. Our last term we'll look at today is this scenario. This scenario has to do with gravitational forcible inertia. Watch as this triangle hits those trains over there. Did you see it? That has to do with gravitational forcible inertia. Do you see how this triangle is crushing these trains? That's because of its strength and fortitude. And that, my scientists, is how gravitational forcible inertia is made.